Ramon's house of man.
Dennis.
What are you doing? All right, two hands. Oh, you're going to set them all up and then put them in at the other. Okay, go ahead. Do that. You can do that too. I'd rather you do two hands, but that's fine. Now, okay, now here's the thing. You got to use your other hand.
I am using the.
Okay. Now we're going to make 10. So what do you got? What do you got so far? You got a 9 and a 1. What else?
Well, I'm trying to build like the 2 and a 3 and the 4 and the 5.
Yeah.
Because 2 and 8 like
makes 10. Right. Exactly. All right. So put them in there.
6, 7, 8. That's kind of more easier to do this because
you like more easier.
It goes higher on this number.
Yeah. All right. So when you finish, then you can tilt it up and show us your work. All right. So put the 8 in there and the 9. First the 8, then the 9. I like it. Two-handed. Good job.
8 and 7. That. Oh. 6, 4. 4, 3, 2, 1. All right, I done it.
All right, let's see. Tilt it up just a little bit. No, just like this. Just tilt it. Yeah, there you go. Tilt it up just so you can see it. Looks good to me. All right, so what are your combinations?
So 10, 9, 1, 9, 2, 8, 3, 7, 4, 6, 5, 5, 6, 4, 7, 3, 8, 2, 9, 1.
That's it. Those are all your combinations for 10. Now let's build 9s. Take out your 9s and build those. Okay, now this one, try and use two hands. In other words, build them one at a time. So leave 1 9 in there. And then an 8 and a 1. You can just put them anywhere. It's fine. 8 and a 1, etc. Try to use two hands.
Actually, what?
That's what I mean. Try to use two hands and do them all at once. Put those other guys back.
But I want to do like
put the other guys back. Put the other guys back. McCray. Put the other guys back and do them one at a time. All right, now a 4 and a 6 at the same time. That's 6 in one hand. Use your other hand now and grab a 4. The other hand, your other hand. Yeah, and stick it in there. And then what? A 5, and then use your other hand to grab a 5. Oh wait, but 5 and 5 doesn't make 10. You can't use. What are you going to use? How are you going to make a 9? That one. Okay, there you go. All right.
And then after, and then after.
All right. See, you're thinking ahead.
And then the 7. And then a 2. Then a 8. 8.
I like it. Tilt it up again, just so we can see. A little more, a little more. Don't worry, they won't fall out. You can tilt it pretty far, actually. All right, I like it. Okay, so here's what I did. You just did all the combinations for 10. Here, we'll do that over here. Look.
Are you going to do the 8s now?
If you want to. Oh, wait. Before we get to 8s, before we get ahead of the game, let's talk about what we already just did. So you figured out 9 plus 1, 8 plus 2, 7 plus 3, 6 plus 4, 5 plus 5. Those are all the combinations for 10, right? Now we can keep going, but then we just have what? We'd have 4 plus 6, which is the same. 7 plus 3 is the same, right? Okay, so we don't do that again. All right. What about 9s? Let's do this. Do me a favor. Count from 0 to 9.
So 9.
Just count. Start with 0.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
That's it. Can you see them all? Are they all on the screen? Okay.
9.
Now, backwards. Wait. Let me get a different color pen just so it's cool. How about, what color would you like? Red or green?
You use a blue marker or that?
I already did use blue. Let's use a different color is what I'm saying.
It looks like black.
Okay, let's go black. All right, fine. Count backwards.
Say black.
Count backwards. From 9.
9, 8, 7, 6, 5, 4, 3, 2, 1.
And 0. Look, there's all your combinations. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. That's 10 nines. That's 2 nines. That's 3 nines. That's 4 nines. So here, I'm going to teach you a trick when it comes to nines. So we're just adding up nines, right? So isn't 9 just one less than 10? Right?
I think it is 9.
It is 9. So what's 2 nines? Well, 2 less than 10.
18.
18. What's 3 nines?
36.
Ooh.
36, I think.
Wait, you went too fast. You went too far. I want to have 3.
27.
27. Because it's 3. And see, look. See it? Did you get a cookie?
Well, it's a Z-bar.
Or is it a, I was going to say, or is it a big piece of beef jerky?
Beef jerky would be better.
Beef jerky would be better. Or bison jerky over there.
Here you go.
Got to give you that company that does the bison jerky. So, and they're Indians too. Sustainably made bison jerky.
That's cool.
Anyway, all right, you. 3 7s. Excuse me, 3 9s is 27. My mouth got ahead of me. All right. So what would be
36?
All right. So the next one's 36. All right. Now here's what we're thinking. I've got 4 9s, but only 3 10s. Right? Now here's the thing. You figured out last time. What's 1 plus 8? And it's looking right at you. 9. What's 2 plus 7? 9. If it's a multiple of 9, it always adds up to 9. Watch. So what's the next one? 99. Uh-oh, I just lied. Because 9 and 9 is 18, but oops. 1 and 8 is 9. It's always going to add up, right? 1, 0, 8. Well, 1 and 8 is 9. That's the next one. Well, now look here. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, look. I'm going to use green just for fun. I was supposed to have a red one around here someplace. There it is. I can see it. I don't have to reach for it. Anyway, what are we going to do? 99, 8, 7, 6, 5, 4, 3, 2, 1, 0. Oh, look. I just did 9s all the way out to 20.
Mm-hmm.
What's 1 plus 4 plus 4?
That'll be 9.
What's 1 plus 7 plus 1?
9.
9. These are all going to add up to 9 too. We can keep going if you want to, but I'll tell you what, you could do that on your own time, or maybe with your sister, with Sedona or one of Ryan's. What is that? Your stepbrothers or sisters? You guys can play together. But anyway, there's your 9.
Sister.
Yeah, you do.
Oh.
Here's a fun story. I had a Chinese student, right? He had 4 sisters. I tutored him for a while. He went to college. Okay. He went to college for 4 years, and for 3 of those years, he had the same roommate. When he graduated college, his sisters came to college. His roommate did not know that he had sisters. Never bothered to mention the fact that he had 4 sisters. Never once. in multiple years of living together. It didn't come up in conversation. That's boys right there. Anyway, all right. Want to build your 8s? Sure, why not? Build your 8s and use 2 hands. Use 2 hands. We're getting, you know why we're using 2 hands, McCray? Is because we want both sides of your brain to fire. Right? Because one side of your brain controls this hand and one side of your brain controls this hand. And if you always use this one hand, only one side of your brain is firing. I want both sides of your brains to fire. So grab me a 1 and a 7 and stick them in there.
But I don't want to talk because like right here hurts. So it can sit like inside my cheek, and every time I talk, it hurts.
Okay, so don't talk so much. Just build me some 8s with a 7 and a 1. Start off with that.
Okay.
What have you got? A sore tooth? You got a new tooth coming in?
He asked you a question. Your new tooth coming in? Yeah, he does. He's got a bunch of teeth coming in.
Yeah, that's what happens at this age. Yeah, that's another thing. The other thing that's going on, try to use 2 hands, is that that little boy right there is producing tremendous amounts of testosterone because he's got to turn into a man eventually. So the running around and getting out and playing is hugely important because all that extra testosterone makes him want to move his body. All right, put that 4 in there, and then what do you need if you're making 8? Yeah, another 4. Use your other hand.
So what fun?
Ooh, is 5 and a 4 gonna work? You just use 4 and a 4. 5 and a 4. Maybe 2 more. Yeah, a little too big. Excellent. Actually, you can stop after 5, right? Because you already have 5 and 3. It's just you did it with 3 and 5, but it's the same thing, isn't it?
Mm-hmm.
All right, build me some 7s, and I bet you find out there's hardly any combinations for 7s at all. In fact, you didn't have to take any 7s out. Just leave them there and build me some 7s. Start with a 6 and a 1. Excellent. And then what? Oh, you skipped 1. Yep. And then what are you going to do? If you get a 2, what do you need to make a excellent? And then what? Yep, a 3 and fine job. That's enough of that. Let's play something else. Oh, hey, slide those over a little bit. And don't try not to knock the 100 off the table, but just slide your tray out of the way. Okay. And then, like I said, during the week, try to build something cool and send me a picture of it. Okay. Let's play this game where you make some rectangle for me. What was this one called? When I have it on the smooth side, you remember?
X10, I think.
Oh, let's try again. X square.
Oh, X square.
X square, yeah. Okay. What was this one called when I had it on the smooth side?
X10.
Just plain old X. Just regular old plain old X. All right. And then what were these? These are the units, right? Okay, so slide your tray out of the way and grab an X square and put it in front of you. You got to have some room to work. Just slide it sideways, or yeah, there you go. And then grab an X square.
I got one right here.
All right, got one right there. All right, so here I'm going to put the code on the wall or on the board over here, and you are going to turn it into a rectangle. Are you ready? So that tells me X square. We'll start off super basic. 3x and 2. We already did this, but just for fun. So get out 3x, which is 3 of these guys. Yep, and 2 units, and stick them in the corner. Now, can you remember what are the factors? Ryan, you may need to get a piece of paper so that we put him in a position where he cannot fail.
Square.
You got the whole thing I told you was x squared, 3x, and 2. Now cover it so all he can see is the top, the x plus 2. So cover the block with the paper.
Cover the
So
whole
that all he can see, keep going, just put the paper on the blocks, just put it on top of the blocks, and then all he can see is x plus 2. There you go, right there. Perfect. So you see right there, what is that side right there?
X2.
2. Now cover it so he can only see the other side, which is x plus. Well, he'll tell me. Just the edge, not the whole thing, just the edge. Move it over a little more so that all he can see. Yeah, there you go. What is that?
X unit.
X plus 1. And x unit is fine. X plus 1.
Oh,
All
I see.
right.
You're doing quadratics. Okay, got it.
Yeah, we're fooling around with quadratics. This is a trinomial, but if you look in front of you, McCray, pick up the piece of paper. Right? Okay, so what do you see? You see an x squared, right? Let's see, you did it so that you have 2 on top, and oh wait, you had 2 on the side and 1 on top, right?
Mm-hmm.
Okay.
So
Now, when we look at this, and so I got to put my 2 right here. Now, when we look at this, can you see 1, 2, 3, 4? That's why we call them quadratics. Look, there's 4 parts there, but these 2 parts are the same. So this is a trinomial. What's a tricycle? How many wheels does a tricycle have?
4.
That would be a quad. How many does a tricycle have?
Oh, 2.
That would be a bicycle. How many does a tricycle have?
3.
That would be right. 3. Right? It's a tricycle. 1 wheel, 1 wheel, 1 wheel, right? You do like this. And then they put the little thing on there. Don't you have a tricycle? I had a tricycle when I was little. Or did you go directly to bicycle?
He had a tricycle for a brief time. He went to bicycle pretty quick.
Yeah. Bicycles are more fun than tricycles.
I actually didn't know that's why it was called quadratic.
See, everybody learned today. Okay, but see, that's why I think that's what I mean, and that's what was confusing. And why is it a quadratic if that's a 2? What the heck?
That's exactly what I used to think. Exactly.
Yep. Me too. Like, why do we call them quadratics when we're only up to 2? And there's only 3 here, but that's why. All right, little boy, you are doing great. Let's do bigger, because bigger is funner. How about 4x and 3?
I was about to do that.
Okay, excellent. And see, here's the thing, right? What we're doing here, I'm not so much interested in the quadratics and the algebra. I'm interested in the fact that 1 and 3 is 4. And that pretty soon we're going to start doing some basic multiplication. Oh, wait a minute. Dude, you've got 4x and 4. I only want 4x and 3. You made a square. That's excellent. But I need to figure out how to put a 3 in there. Boom, done. Get the 2 out of there, the 2 2s, and grab your 3. All right, once again, tell me the factors.
So, x 3.
X plus 3.
X 3.
And what's the other factor?
X. Oh, I need to put this over.
Well, you can leave it like that. You can leave it. You're fine, unless you want to change it around, but you're fine. Just read the across first. Put the piece of paper so he can see only the x plus 1. Okay, that's the up. That's this. Right. What's that?
X
Plus
1. X1.
And
X3.
x plus 3. Excellent. All right. Now, and on our way here, you figured out that x squared 4x and 4 was x plus 2 and x plus 2, right? Okay. But I didn't want 4. I wanted 3. Excellent. You did a good job. All right. Now, x squared 5x and 6.
So,
that's you.
I know.
You need 5 of these. He already got it. Look at him. Super fast. Tell me the factors.
X2. X3.
X plus 2. X plus 3. Can you say it?
X plus 2. X plus.
There, and here I can see x plus 3. Right?
I don't want to do the plus because the plus doesn't really matter.
It totally matters because later on there might be negative.
Exactly. It matters for now.
So, yeah. Okay. Now, let's get bigger. Since you're doing so well, are you ready to do it little bigger ones?
Uh-huh.
All right. Are we struggling? Is it hard? Is it super hard? How old are you?
7.
You're only 7. Oh my God, you're doing algebra. Oh no.
You just surpassed Riker.
I don't even know algebra.
I mean, not like this.
Not like this. There you go. And see, as he gets older, we'll add more. Let's do x squared 7x and 12. Yeah, I've seen high school girls cry over stuff like this.
Sedona used to cry over stuff like this.
Yeah, well, how come you had a phone number? You could have called.
Hey, I know.
And I like choke Justin's neck because look at your toys. They're so perfect. You can tell he never used them once.
I know it's in my dreams.
By the way, this bag is
So
really nice.
you dreamed about the blocks a little bit? That happens.
I know it's in my dreams.
The woman who sewed this together did a very good job.
Done.
Yeah, that was a Mormon woman in Utah.
X4, X3.
Yeah, done. X plus 4, X plus 3. Wait a minute. Which way did you do it? Oh, you went the other way. You went X plus. It doesn't matter, but it's just that this is the across and this is the up. All right, let's change it around. You got X plus 4, X plus 3. Let's change this to X squared 7X and 10.
I don't know.
You can't use the same anymore. Oh, you already figured it out.
Yes, I know it's in my.
How you gonna get? I wouldn't use 4s if I was you. What would make 10 easy?
Oh,
Uh-huh.
I got this in the bag.
All right, so
I know
all the
that-
different things, right? So tell me the factors.
X2,
Mhm.
X5.
You got it. X plus 2 and X plus 5. What do we have going on here? I'll tell you what we have going on here. We've got some multiplication. We got some add-ins. We got some spatial recognition. We got some hand-eye coordination. And now take your piece of paper and a pencil and draw this one. I'll draw one and you draw one. I'll draw it like this. Can you take a piece of paper and just draw this? It looks like this. There's my X squared.
All right, I'm gonna need a pencil.
Yeah, pencil is good. And then look, 2 over here.
Thanks. Who was it?
This Briggs, but I told him he can come back up here, done.
All right, I'm gonna draw it.
And I'm lazy. I'm not going to draw 10 dots. I'm just going to put 10. What? Just look. Don't look at mine. Look at right in front of you. You're drawing the thing that's in front of you.
I'm lazy too.
Let's see. You're lazy too. Good. I'm happy. Let's see it. Okay. So what we did, we get the information across the corpus callosum. The left and the right hemispheres must talk to each other. All right, let's get bigger.
It's gonna be 9.
Do you want to do 9? Let's do 8. We didn't get to 8 yet.
Okay, that. Let's get the 8.
We'll get to 9 in just a second. 8x. Ooh, I'll make this one fun and easy. 16 in the corner.
I got this in the bag. Oh.
Got to fit 16.
See that? And then a 4.
Mm-hmm.
And then another 4. Like so many 4s.
It's only 4s.
Yeah, divorce. Oh, that is divorce. But, beep, but,
Hey, McCray,
but,
what shape is this?
square.
A square. 16 is a square, isn't it? In fact, look in front. Isn't that whole thing a square?
25 is a square too.
25 is also a square. You're right. So what are my factors over there? Tell me.
X4. X4.
X4. All right. So X plus 4, X plus 4. Oh, no, that's too much writing. No, too much writing. Wait. Hey, McCray, look.
What?
Look at this. Look. I'm going to say that this is X plus 4 squared. In fact, I can see that 4 squared is the same thing as 16. Right? All right, now here, I'm going to give you this thing. You know what that symbol is?
Like a heart meter, I think.
This thing right here. Like a heart meter? What
Yeah,
that symbol? That symbol right there. I'm trying to make it look like it's supposed to. There you go. What symbol is that? Do you know the name of it?
A V and
A V. Okay, this symbol, it looks like a division symbol, but it's called square root. That's a square root sign. All right. Can you say square root?
square root.
Square root. Now, here I'm going to tell you, and you're going to tell me. I have the square root of 16. That means, see this little thing right there? That means I only want to count one side. Because, McCray, isn't a square all the sides the same?
Mm-hmm.
Okay, I mean, look, it's a square. All the sides have to be the same. Otherwise, it's not a square, right?
Mm-hmm.
Okay, so this thing right here says, I take my square and count one side. So I'm going to take my 16 and count one side. What's one side?
4.
Done. Okay, I'm going to take my 100. What's one side?
10.
Oh, you're crazy. All right, how about, I'm going to take 9. Now, can I take 9? Well, that's not a square. Oh, look, 9. What's one side?
9's a square.
It is when I make it like this. What's one side of that 9?
Not a square.
Is that a square or not? You tell me.
It is a square.
All right, so what's one side?
Like
one side.
How many is on one side?
3.
3. That's it. Look like you were trying easy, exactly. Look like you were trying to make it hard there for a second. Oh no, it's square roots. He's only 7. Why are you teaching this 7-year-old about square roots? I just came from a math teachers conference where everybody was struggling and math was hard, and they all knew math was hard.
Yeah.
And you have to acknowledge that math is hard. Otherwise, it's a slap in the face to children that are failing in their messed up system for teaching mathematics. Anyway, what's the one side of this?
5.
Okay, so if I said, what's the square root of 25?
5.
Okay, so now I'm going to do this. 25. Look, the square root of 25. What's the answer?
5.
Done. Oh, wait, I'm going to change it. This is square root of 100 now. What's the answer? It's this one.
10.
Done.
10.
10. Done. And it's the other one. Yeah. Square roots. All right, here. Right. If you're not going to have fun, I'm not playing with you if you don't want to have fun.
Yeah, have fun.
I am having fun.
By the way, I don't think Rachel knows what a square root is. Don't tell him.
All right. So now I'm going to change it up a little bit. See this right here? We're going to pretend that this is a gallon. You got it right in front of you. And what we're going to do is we're going to pretend that this is a gallon. Okay. So if this is a gallon, have you ever heard of a gallon before? That's liquid, right? Like a gallon container, a gallon of gasoline. We're just going to use it.
Like a jug.
Yes.
Yeah, it usually comes in a jug, but we're going to just represent it like this, right? Look, this is a gallon. So this would be a quart. How many quarts in a gallon?
4 quarts.
4 quarts in a gallon. All right. Now, this is a quart. We're going to say that this, dun, 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 is a pint.
Ooh.
How many pints in a quart?
4 pints.
Wait a minute. This is a pint. How many pints in a quart?
Oh, 2.
2. Now, if I now wait, excuse me. Pint. This would be a cup. How many cups in a pint?
You mean a quart?
No, he means
Okay, I'll ask you that one then. How many cups in a quart?
3.
Try again.
Ooh.
okay.
There's 3 more that you need, but how many total?
Oh, 3 ones.
Well, how many of these do I need to make one of these?
You know.
0.
Oh,
0. If I use 0, am I going to make one of these? So how many of these do I need to make one of these? How many cups in a quart?
3.
Try again.
2.
Well, I've made half. That would make a pint. What if I keep going?
I'm confused right now.
So how many cups do I need to make? Come back. Come back. All right. How many cups? You need 4 of them. All right. And then I need 2 to make a pint. And then your mom or Ryan or whatever, you can show him with an actual gallon, an actual pint, right? But here we're just using blocks to play around. And we took a little side course there, and we'll come back another time.
Oh,
Uh-oh.
the block saved you.
Yeah.
oh, geez. Oh my gosh. He fell in. He fell in this,
And then the block saved him.
and he stayed on. I know I put that there so it wouldn't close.
All right. Excellent.
He's still
Good
not.
job. Okay. Now, here, let's get totally crazy.
Oh my gosh, we dropped it again. This laptop sucks. I should have used my other one. McCray, stop shaking the table. There you go.
All right. Here's some thinking. Uh-oh, we lost them. They'll be back. That'll give me some time to set this up. Shall I sing? I'll sing. La, 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 la. Oh. I got 6. That's all there is. 6 times 1 is 6. Oh, wait, you're back. Okay. So, I've got x squared, 8x, and 16. You see it in front of you? Oh, put yours back. Put it back together again like how you had it. Make a nice square out of it.
Rectangle.
Excellent. Now, can you tell me what the square root of x squared, 8x, and 16 is?
I think.
What's one side? Just look at one side right in front of you.
Oh.
Ryan, put a piece of paper there so you can't lose.
Oh, sorry. Here, straighten it out.
Just any one side. Just one side, because any side. And then we're going to talk a little bit more. Yeah. Now,
X4 and X4.
you just need one, because one side is x plus 4. Now, do me a favor, Ryan, and put it on the other side. Just slide it over so he sees the red and the blue.
Like that?
Yeah, there you go. Perfect. Can you see that that's also x plus 4? Because look, the distance from here to here is x. Right? And then these little butt ends over here, 1, 2, 3, 4, right? So no matter where we are on this thing, it's x plus 4, the sides. It's not just the sides, though. My point is that it's from here to here, across, right? So wait a minute. I'll draw a picture. So what I'm saying is that, look, there's my x squared.
I know what you're talking about.
Yes, you already factored it. 1, 2, 3, 4. 1, 2, 3, 4. And then I am going to put the little guys in the corner. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now what? Look. From here to here, it's still x plus 4. From here to here, it's still x plus 4. From there to there, it's x plus 4. From here to here, it's x plus 4. And from here to here, it's x plus 4. I don't want you to get caught up thinking it's the edges.
Diagonal? What about diagonal?
Oh, that's a whole other. From here to here?
You say, yeah.
Yeah. That's a whole other thing for another day. Excellent question, though. What is the diagonal? In fact, on this, what's the diagonal?
Everything's x.
From here to here, what's the diagonal? I'm just going to tell you right now, and later on we'll actually figure it out. The diagonal from here to here, if this is 100, or if this is a unit, this would be square root of 2. If this was 100, this would be 10 square roots of 2. But anyway, we'll come back to that another day. But see, excellent. See, he's curious. He wants to know stuff, right? He wants to know that things about the world around him. And mathematics can help you figure stuff out. All right, let's get bigger. You said you wanted to do 9x, right? Let's do x squared, 9x, and we'll do, to start off, we'll do 18.
That should be easy enough.
That should be easy enough. But wait, math is supposed to be hard. We're factoring polynomials. Do you know what the average student gets in algebra when they take algebra?
I'm gonna guess a C.
You'd be guessing really high.
Really?
What do they usually get in algebra?
I don't know.
F.
Do they really usually fail?
The most common grade in algebra is F. That's the mean score in algebra for the first time they take it.
Interesting.
When they take the compass test, 60%, because it's algebra heavy, 60% of students take the compass test and fail it the first time. None of my students have ever failed the compass test. In fact, most of them ace it. I had this one child, she was autistic. When I met her at 17, she was coloring balloons. And in 3 years, she passed the compass test.
Do you think you have it this time, bud?
I don't know if I have it.
All right, how are you gonna get 18 in there?
Yeah, where's 18 at?
How are you gonna get 18? Are you gonna try and build 18? See, this is a bit of a challenge, this one. A little thinking. Are you gonna build 18 with 4s? How else could you build 18?
2 9s.
Oh, 2 9s. That's true. Yeah. Absolutely, that's true. I don't think you're gonna be able to fit 2 9s in there. You don't have enough 10s, or you don't have enough X.
You were close.
So what else could you do? Oh, Dad's helping. Stick some guys in there and see. That's exactly not going to fit. You can tell it's not going to fit. So get that out of there.
I know it's not going to fit.
All right, so fit something else. Grab something. There you go.
There you go.
Yep, put another one in there. Now how many?
18.
Wait a minute. You only have 2. Wait a minute. You only have 2. Does he have 3 6s or 2? I can't tell at this end.
He's got 3. He's got it.
Okay, because I got. Okay, so can you count? 6, 12, 18, right? Now tell me the factors. You shave off all your hair? Is that what I just noticed?
3.
Me? Yeah, I did.
X plus 3.
X plus what?
X plus 6. X plus 3.
There you go. Okay. X plus 6 and X plus 3. See, I'm not interested in graphing this. We're not, right? Oh, wait, you did 6. What I'm interested in is 6 times 3 is 18, and 6 plus 3 is 9. That's what I'm interested in. At this stage of the game, he's 7. We're just playing. And we are going to evaluate? No, we're not going to evaluate. Well, we could evaluate, but we'll do that another time. Where we flip the blocks over and we just count 10s. But all right, now what I'm going to do is I'm going to make this trickier. You figured out 18. Can you figure out how to put 20 in the corner?
Well, I'm going to need X10 for that.
Well, I don't know. Let's see. You're definitely not going to be able to use the 3 6s.
True.
Oh, you just figured out another one that I didn't ask. I want to put 20 in there. How are you going to get 20 in there?
20. That's a tricky one.
Yeah.
Got to add up to 9 though on the two sides.
Yep. Does he have 9x?
Oh,
Count your. Make sure you got 9x.
you got X. Okay.
Mm-hmm.
Okay. Well, then I just got to figure out how to put 20 in the corner.
So you got to put 20 in the corner with that one.
I'll do that one just for fun. Can you see that you just figured out x squared, 9x, and 14? That's excellent. So you did x squared, 9x, and 14, but I want 20.
Yeah, he doesn't want.
So I was going to ask you to do x squared, 9x, and 14 next, but you already did it. So here, let's just do it right now. X squared plus 9x plus 14. Tell me the factors that you just made.
Can
X plus?
X7,
Uh-huh.
X7, X2.
There you go. Okay. 2 times 7 is 14. I want 20. You're going to have to change it around.
So how are you going to move? You can move some of your X's to the other side. And
Yeah, you're going to have to move your X's around until you can get 20 in there. That was 18.
Oh, I know this now.
Let's let him play. That's the whole thing.
I'm getting it.
I think he went past.
He did, but he's going
But
down.
he'll get it anyway.
Yeah. Do you want him to do it in one direction?
And it doesn't matter. Absolutely. It does not matter. What I want him to do is play around, have fun, and figure it out. There's no one way to do it.
No, I know. I just making sure.
Yeah. No, well, you'd be surprised at how many math teachers think there's only one way to do it. And to the point where if you don't do it their way, you get the right answer. But if you didn't do it their way, they're still going to mark it wrong.
Right.
All right. So what are the factors? You were telling me
X4, X plus 4, plus 5.
X plus 4 and X plus 5, because 4 times 5 is 20 and 4 plus 5 is 9. Fine job. Okay, before we run out of time, just factoring. You want to keep factoring or you want to do something else?
I'll do something else.
Yeah, let's do something else because you got this down. This is wired. This is old hat already. You can build any of these guys. I'll give you one more just for fun and then we'll quit. Just for giggles. Because I already know. X squared, 10x, and 25. And I'll give you a huge clue. I want to know the square root of that. So build me that. You need 10x. Make sure you have 10.
Oh. So I'm going to make it 25.
Mm-hmm.
I got this in the bag. Don't.
Ryan, you got have you got red cups?
Do I have what?
Red cups.
I do.
1 or 2 red
get
cups.
them ready, but I don't know what you
All
guys
right,
did.
yes, you're already there. Okay, cool. We'll set it up in a second.
I got this in the bag.
You do have it in the bag. Tell me the square root of x squared, 10x, and 25.
X5, X5.
Well, just one side, and you're correct. That will be x plus 5. And if I told you to factor it and I got rid of this big long square root sign, you'd be correct. It'd be x plus 5 squared.
Cool. Can you make a
All
square?
right. You want to put this? You want to draw a picture of this? One fast one? Yeah, just a quick picture. Just a quick sketch. Here, I'll do it too. Here's my x squared. And what? I gotta put 5 over here and 5 over here. And then I gotta put 25 in the corner. Once again, 1, 2, 3, 4. It's a quadratic. But these two are the same, so it's a trinomial. Mm-hmm.
And also you can just do 2 5. Just do 2 5. It's the same.
Okay. So put your other blocks away, and we're going to play What's Under the Cup.
You have to put 3 cups down.
I have to put 2 cups
We're
down.
just gonna start with 1 cup. 3 cups is, to start off is we'll work our way up to 3 cups.
Do I
All
have
right,
to hide
take your x squared, 10x, and 25 and put them away.
All right, put these away. Yeah.
All right, so you need 2 3s for an equal sign.
Mhm.
All right. On the one side of the cup, okay, so your cups will be over here. Put the cups on the other side. All right, there you go. Yep. All right, now McCray, this part where you got to close your eyes or hide under the table or something. Okay. Put that in the cup.
Yep. Hold on, where is it?
Okay, put the 6 outside the cup. Yep. And then, of course, on the other side of the equal sign is one of these.
Do we burger colors? Oh, I put a 4. Oh, never mind. Got it. I thought I had put. I forgot what we put under the cup.
I heard it.
All right. All right, you're ready, McCray. Go.
Oh, 4. I heard 4.
I know. I screwed up. I thought I remember putting a 3 in there, but we put a 4 in there.
Got it. All right. We're gonna try another one, but this time you're not going to hear the answer.
You're not going to hear it this time. Turn around, Uber.
And in fact, just for that, you're going to get 2 cups. Give him 2 cups.
All right. Where do you want the other cup? Which side?
Let's see here. Let's do this. Let's put this in the cup. And another one. Yep. I'm gonna put a cup over it. We're gonna have 2 cups, and the cups have to be the same. All right, now, we're gonna put this outside the cup. On the other, yeah, there you go. And then give me the blue one again. Go right there in front of you. Yeah, there you go. Fine. And turn it this way. Yeah. There you go. All right, McCray, you're on. Dun, dun, dun.
3.
What did you say?
3 and a 3.
All right, pick it up. I don't know, McCray. Were you looking?
No.
Okay.
I'm putting my hoodie under.
All right. So we'll make another one. This one's gonna be a toughie. This one's gonna be tougher. All right, we're gonna get crazy. Are you ready?
Oops, just throw equal signs over.
Yeah, there you go. Put one of each in the cups. Yes, that one. And then put 3 outside the cups. Yep. And then you need a 10 and a 5.
Get used to the colors. Hold on.
Yeah. Perfect. Excellent. All right, McCray, you're on. This is a toughie. Do me a favor and put it down there with the 10 instead of the 5. But it's the same. But yeah. Can you see now that you have 7? Right?
6.
Wait. What'd you say?
6 and a 6.
Oh my goodness. How'd you get it so fast? All right. So here's what you did.
Because I did it while she was up here.
Yeah. I see.
12.
Okay, so here's what you did. You said, here's what we did, McCray.
You like this?
2x plus 3 is the same thing as 15.
Mhm.
Right?
Mhm.
Nothing hard about that. Okay. And then what you did is immediately you took the 3 out. We're going to talk about hero 0 another day, but there's 0. And then you figured out that 2x had to be the same thing as 12. And so you had to do a little addition in there. And then you figured out that 1x had to be the same thing as 6. And look how fast you are. Look, you did it faster than I can write it. Right? You knew the answer. All right. So we're going to try another one then, if you can do them like that. No cups this time. You're just going to look up here. And for the teachers watching, you guys go directly here without the kinesthetic component, and you lose 2/3 of your class.
Yeah.
Because like Sedona, what's Sedona? Sedona is absolutely a kinesthetic learner. She's fully kinesthetic.
Yeah, she has to be.
Cheerleading and what do you call gymnastics and volleyball and all kind of sports, and she was good at it too, right?
And,
Okay.
and she gets it.
All right. This is not kinesthetic learning right here. This is male visual learning. All right, McCray, you don't have to close your eyes anymore because yeah, you can look.
He's going to change it though.
I'm going to change it though, exactly. So now I'm going to have 2x, and we're going to get crazy. Plus 4 is the same thing as 12. Can you tell me what x is? What's under the cup? Because that's what we have. We have 2 cups. Can you do it? All right, here's the thing.
2 and 2.
Oh, 2 and 2. 2 times 2 is 4, and 4 plus 4 is only 8. So here's what you're going to do. Close your eyes. Close your eyes. All right, now set up the problem for him.
Did.
Oh, you already did?
Yeah.
All right, cool. Now figure it out.
Four and 4.
Got it.
Yeah, I didn't even put them under there because I knew you were going to get it.
So you're right. It would have to be 2 4s.
It's 2 4s. You're right.
All right. Why? Because 2 times 4 is 8, and 8 plus 4 is 12. And do you see that it won't be long before you don't need the cups? But right now, it's like training wheels. And then eventually we take the training wheels off. All right. You have done a fine job. Would you like to listen to some multiplication rock just for fun? Or do you want to keep playing math? Oh, you can do it on your own time, but we got to do some multiplication rock. That would be your homework, is to listen to some multiplication rock. But let's play some more of this then. Let's go get another cup. Let's get 3 cups. Let's get crazy.
3 cups.
3 cups. All right.
That'll be a triple.
Yeah, 3x.
All right. See, and then eventually what happens is you can play what's under the cup, and then he makes problems for you. And then you make problems for him. And then here's the other thing. McCray, have you ever had a birthday party?
I had a birthday party.
I'm just saying, if you have a birthday party and Ryan's the only one there, is that a fun birthday party, or would you rather have other guys at your birthday party?
Other people.
Okay, see, that's the same thing with tutoring, right? Me and him, you want to have more guys. If we had 4 or 5 kids, we'd learn faster, better, more, but it's hard to get groups together. All right, so you got 3 cups. Let's do it. Since we're moving up the ladder, put one of these in each cup. Yep.
Close your eyes.
Close your eyes, you.
Okay.
All right, and then we'll just put something small on the outside of the cup. Let's put this on the outside of the cup. Yeah. Okay, either one.
This is good.
All right, and then you need.
Yeah.
You need a 10 and 8.
Is that brown? No, not brown. Brown. Yeah.
Yeah. Yep.
There you go.
All right, you're on 3 cups.
I feel like I've done this before.
I don't think you can do this one. I think it's too hard.
Dun 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 dun.
So 15. 3 5s.
You did it. You did it.
Fine job. Let's do another one.
All right, 3 cups again.
3 cups again.
Oops.
What should we do for this one with 3 cups? Let's go with, let's get crazy. We're getting big, McCray. So you'll need 3 of these.
I can't hear you.
Yeah, you can. Oh, gosh.
And then just put one of these on the outside.
Okay.
And then these.
Yeah.
All right. Put the 2 on the other side is the only thing because it's 2. Yep, that's it.
Yep.
Done. All right. You're on. Look how big we got. You're doing big kid problems now. Never got the x to the third.
On.
Tricky.
Wow, look at him thinking.
This is the hardest one.
Practically see the steam coming up out of your from your hoodie. Oh, don't look.
Oh, don't cheat.
7.
You cheated. No, you cheated.
You totally cheated.
You're a loser. You're a loser. Cheater.
You knew it was 21, and in the future you will know that 3 7s is 21. But right now he didn't know. All right, fine. So he finally. All right, but you're right. Do me a favor and take out the 3 7s and put them next to your 22. Make it one long equal sign. Let me get one long thing in front of you.
One long
Yeah, there you go. 2 10, right? And then put the 2 on the other side because it's not 2 and 2, right? The 2 goes last. The 10s come first. And then you need the unit. Put the unit there. Do you see that you got a really long, skinny equal sign?
Mm-hmm.
That 3x, but you figured out that 3x was 7, sort of. And 1 is the same thing as 2 10s and 2.
3 7.
Trace.
3 7.
Yes.
3 7.
Siete.
Who taught you Spanish?
My Spanish teacher.
Oh, good job. Okay.
Yeah, there you go. So it's 3 7s. You're correct.
Mhm.
Siete. Oh shoot! I used to know how to say it.
3 7.
Ask your teacher how to say 3 times 7, and tell me next time.
I didn't know you guessed.
Okay. I only want to do a couple other things. We're technically out of time, but have you got places to go and people to see, or do we have a couple extra minutes?
We have a couple extra minutes.
All right, let's do a couple extra minutes. Let's just do this. Grab the other the what do you call the black one that has the basic operations pieces in it, and basic operations pieces are these. And
Wait. Which ones are they? They might be back in the case. Hold on.
yeah, they're probably.
Just the pieces of paper or whatever.
And they have these.
Oh, let me see what you're looking at.
You'll see
yeah.
them.
Yeah, I'll find them.
It's one of the racks. I am very pleased with you, child. You did a really good job today.
I'm turning to my ball mode.
What are you doing?
I'm turning to my ball mode with my Snuggie.
Excellent. Do me a favor. Count by 7s. Can you count by 7s?
7, 14,
21.
21.
Hold on. Are these supposed to be cut up or anything? Are they supposed to be the way they are? I think
Yeah, they're supposed to be the way they are.
Okay.
All right, so get these guys out.
Yep.
Or just at 1 for the moment.
There we go.
Yeah. Okay, so let's take a look at this. How many do you think this is? Hand him one of these.
1,000.
1,000 is the right answer. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000.
Yeah.
1,000. Now wait.
A long time to count 1,000 with ones.
Yeah. So this is 1,000. It is 1,000 ones. Look at them. That's 1,000. There's 1,000 of these.
Yeah,
Right.
it sounded like
From here to here, how far is this? From here to here. Just
10.
from here to here.
Yeah.
Count it. Count it. You can count. It tells you.
He said it. He said it.
What did he say?
What'd you say?
10.
10. It is 10. Okay, I just didn't hear you.
Yes.
All right. So what's this side then? What's this side?
Oh yeah. How many are across here? What you can do?
1,000.
No.
The whole thing is 1,000.
This side.
How long is this one side? Look.
You can do it.
Look over here.
And this one's 10, and this one's 10. How many are on the way across?
100 times.
100. 100. It's 100 10 times. Right? Look. Here's 100.
Oh.
And here's 100. These are both 100. This one is 10 by 10. This is 1 by 100.
Yeah, this
there you go.
one
There's
is
the bags.
so skinny.
Long, skinny one.
It's always flexing on me.
So do you think these are the same?
Yeah.
So see what we did? All we did, Ryan, is cut these guys up like this and put them in there, right? So now I have 100. All right. So here's the other thing. That's base 10. We're just going to name some names in algebra. In algebra, this, what do you think we're going to call this? If we're in algebra. What do we call this? What do we call this one?
X cube.
X square?
X square.
X square. Now, you're right. Is this an X square?
No.
I agree. Because it's long and skinny, it's not a square. But it's the same when it comes to quantity. It's 1 by 100. And this is a 10 square. Could we call this a 10 square? No, but could we call this 10 to the second power? Definitely.
Yeah.
Right? Oh. Uh-oh, what happened? Okay. Had a slight issue there. All right. Could we call this 10 to the second and 10 to the second?
What?
10 to the second. 10 to the second means 10 times 10. Oh, we just talked about this, and let's do it some more. 10 times 10. Like I said, it takes too long to write it. So let's just write 10 to the second. 10 to the second is the same thing as 100. See it? It's 10 times 10. It's a 10 square. That's a 10 square. 10 squared is 100. Right? Okay, now on this one, we don't have a square. We just have a long, skinny guy. But this could still be a 10 square.
And it's still 10 tens, huh?
Right? Okay, and then what would this be? Well, this would be a 10 square times a 10. So,
uh-oh, that's tricky.
Exactly. So now we'll have
What's 10
times 10. That's the across, right? Times 10. And now I have 10 to the third, and that's the same thing as 1,000. 1,000. You see all the symbols? And instead of writing all of that, I just write 10, 3, right? 10 to the third, 10 cubed, and that's the same thing.
Are there 10 of these to make a cube?
Yes, actually, if you pile up 10 of these,
We put 10 of these.
we'll make a cube.
We'll make a big cube.
Now, here's the thing. If you try to teach a lot of the mathematics with a cube, I assure you, you're going to have a bad time.
Okay. It's still fun though.
But you want to make a cube. And there it is. Can you see it?
It's like a big box.
Like a big box, exactly.
So yeah, like a Rubik's Cube. Yeah.
Yeah, just like that.
Mm-hmm.
But see this right here? If I try to teach third power algebra with this, we're going to have a bad day. Right? So I'm going to teach third power algebra with this. So here's the thing. Now that I know that this is 10 to the third, now I'm just going to say, you know what? I'm going to call this x to the third. And you know what it is? It's x this way. See, it's x by x squared.
Do you think that's because
x to the third? So this is an x to the third. This is x squared. This is also x squared. These little guys that are in the package, that's just an x or a 10. And then, of course, there's units, but the units are just going to get lost, so we're not going to play with those at all because they're too tiny when he's 7.
Do you think that the cube math is tricky because it's difficult for people to visualize the volume?
And it's also physics and not arithmetic. But yeah, I'll show you something very quickly. we'll give it to you. We'll give it to Ryan, and you can just follow along. So here's what I want you to do. I'm going to tell you to get out. What was this one called again?
Who's this one?
McCray. What's this one called?
1,000.
1,000. I'll take it. And if I'm in algebra, we're going to call it x to the third.
X to the third.
Can you say x to the third?
X to the
All right. Now, wait. Get crazy. We're going to count these.
And then will be.
How many do I have?
Ooh, good one.
10.
How many of these do I have? How many of these do I have?
7.
No,
How many of them do I have?
How many of the green pieces does he have? How many?
4,000.
Do I have 4,000 of them? I have 4,000s. You can say that. You can say that. You can say 4,000s. But here's 1, 2, 3, 4. Just because the numbers got big doesn't mean you're gonna have to try to get fancy. We're counting 4 of these things.
4 of them.
There's 4 of them. Right? Okay. Now I'm gonna get fancy. Let's see here. I got these, and I'll do this.
Uh-oh.
Now, how many? Do me a favor. Give him 4 of these and 2 of these, and let him count.
Okay. Let's get these. 1, 2, 3. 4 of those.
Mm-hmm. And 2 of these.
2 of these. They're in this bag over here. They're all tucked away. How many do you have?
All right. How many you got?
4 long pieces. And 2 squares. What do you got?
That would be
Ignore this one.
Okay.
So how many you got?
What do you got?
That would be so. That would be
Look at them. How many do you have?
100. I think.
How many of them do you have?
How many of those do you have?
4.
Well, you have 4 here. What about these 2?
There you go.
600s. You are correct. 600s. What are we counting? We're just counting.
Mhm.
Now, I'll tell you what. Now I'm going to tell you what. I'm going to say that these aren't hundreds anymore. These are x squareds, right? These are x to the second powers. So here is 4x to the second power and 2x to the second power. How many x to the second power do we have?
600.
No.
Now we're counting x to the second power. Here's 1x to the second power.
500.
Here's 2x to the second power.
Pay attention.
We're calling them x to the second power. We're not calling them 100 anymore. We're calling them x to the second power.
2.
How many of these do I have right here?
200.
No, right in front of me. What's that?
2, and we're calling them x to the second power.
And then now we have 2. And if we add these 4, how many do we have?
6 to the 2.
Just 6. Wait. Listen, McCray.
6.
6x squared, or 6x to the second power. We're not calling them hundreds anymore. We're just calling them x to the second power. How many do you have? All right, let's do it again. Let's add another one just for fun. Now, how many x to the second power do I have?
One more. Pretend to give one more.
3.
3. That's it. 3x to the second power. Got it. All right, wait. Now, how many do I have? 3 and 1.
4.
X to the second power.
Yes.
All right. Now let's try again. Now I have 3 and 3. I got 3 of this kind and 3 of this kind. How many do I have?
6 to the x power.
6.
6x to the second power.
Yeah. You could say 6x to the second power, or we could just quit fooling around with second power and just call them x squared.
6
Keep it x squared. Even though this isn't an x squared, we'll just call it an x squared. even though, because it's the same, right?
Really?
And we could call it second power, but it's too hard to say. So let's just call it x squared. So watch me.
Man.
Here is 3x squared, or 3x to the second power, and 3 more x to the second power. And you're correct. We get 6x to the second power. Or I could say 3x squared plus 3x squared is 6x squared. Right?
Mm-hmm.
And then I could say if I have an x to the third, that's one of these. Well, actually, let's say 2x to the third and 1 more x to the third. How many x to the third do we have?
Mm-hmm.
Really? If I have 2 and 1, suddenly that's hard to count.
Oh, 300.
3, what are these called?
3,000.
3,000s, but I just called them x to the third. So how many do I have? How many x to the thirds do I have?
X to the third.
Yep, I have 3 x to the thirds. This is how you write it. 3x to the third. That's it. Doing a little vocabulary. We're naming these pieces. All right, so Ryan, just for fun.
Yep.
Take out 1 x to the third plus 2 x squared plus 2x plus 1, and make me a rectangle. In fact, I'll even make it easy for you. I'm going to tell you that one side, I want one side to be x plus 1.
1,200.
Well, I gotta find you an X. We have X here.
So first you need,
These guys.
Those
those are x. Yep.
These are X's.
Those.
The blues are going to be X's. The reds are X squared. The green is X to the third. You want 2 of those. And is there some?
Right. So we only need 1 x to the third, 2x squareds, 2x and 1. Now make me a rectangle out of that. Now, Ryan, you're helping for sure.
Yeah. How do we make a rectangle out of this? Can we do it?
Yeah.
I think we
We
can.
also need a 1. Where do I get the 1?
Now here's what I'm going to tell you. I'll give you you want a big hint?
Yeah.
I'll give you one big hint. One big hint. You need one of this kind and one of this kind.
Gotcha.
That's it. Can't use 2 of these and can't use 2 of those. The only hint I'm going to give you.
How might
Make it into a rectangle. And I
we
told you that one side is x plus 1.
don't have any singles. Hold on. Where are they?
You don't need it. You don't need them
Okay. We'll pretend like it's
because and you only need 1. So you anyway, you'll figure it out where that goes in a minute. I'm sure.
2x squares, right? Here's an x squared. Here's an x squared. What's this one called?
X to the third.
X to the third.
Yep.
Now, how do we make a rectangle out of all these?
Got to have them all stick together.
Make them all stick together. Okay. Let's put these 2 line up kind of nice, huh?
Yep. And can you see that it's x plus 1 right there? I'll tell you what. There you go. Good. Where are you going to put that other one?
Where are we gonna put this one?
Yep. I like it. I like it.
Yeah, maybe we can put it. We can put it anywhere. Can we put it here? No, that make a
I couldn't
rectangle.
put it there.
Can we put it here?
Yeah.
Oh, and then
Do
we
you
have
see where the
one.
's going to go?
The 1 goes right in the corner.
Yeah, ones are super tiny.
So do we make a big rectangle?
We can.
All right. So here's the thing, McCray. You see the side that's x plus 1? And here, wait, I'll draw it. You guys did it long and skinny. I'm going to draw it and it'll be fine. I'm going to draw it like this. Meow. Meow. See that? And then I need a red one. Where'd my red pen go? Right here. And then we did this. Meow. And then you put one over here. Right? There's 2 of them. Wow, let's make that prettier.
That's like an airplane.
I know, kind of. There you go. And then what? And then you put one right here and one right there, and then you didn't get the unit out because it's too tiny, but the unit would go right there. You saw where it go, right? Okay, so I told you that it's x plus 1 across. How far down is it?
Ooh, good one.
Count them all. Count them all.
100.
Wait. Count it all.
Count how many x's do we have across?
Wait a minute. What do we call this? What was the name for this?
Square.
X square. So there's one of them. So it's an x squared. Then what? What's this one called?
A 10.
What's this one called?
X.
X.
X. And then what?
Oh, I see what you're doing.
X10. X10.
And then what? And then what? What's left? Right there.
Tiny little guy.
1.
1. That's it.
Uno.
That's it.
Uno.
Oh no, you're doing third power algebra and you're only 7. Oh God. Oh no.
Pretty
All right,
cool.
that's it. That's all it is.
Pretty cool.
All right, and we're not going to do all the work underneath. If you want to see the work underneath, just count. Well, I don't know, Ryan. Do you want to see that? We don't need to for him, but I'll do it for you just for fun, just so you see. X squared, right, times x plus 1 is going to give me x to the third plus an x. See him? Okay. What's left? Well, we're here. Got to count. There's going to be an x squared. Oops. Give me an x squared. What's left down here? McCray, count. How much? What do you see down here?
Oh, a rectangle.
I know. And what? Count them. What's all the parts of my rectangle? What's that one called?
X squared.
What's those two called?
X.
So how many do I have?
2.
2 X's.
And a unit.
Got it.
All right. So now I got to go across this part. I go across the x plus 1 times, and I get an x squared and an x squared. Let's do this right. Make my symbols correct. X squared and an x. Okay, what's left down here? What's left right there? Can you see it?
What's on the bottom of his thing? What's on the left?
X unit.
X
An x and a unit. So then when I go across x plus 1 time, I go across an x and a unit, and I'm nothing left to count.
I just learned something today. Look at that.
How easy is that? Is there anything hard about that? This is day 1, by the way. After you've seen this 10 more times, is this going to be hard or is it going to be just crackers?
Crackers.
Black soup. Okay. I think we're done for today.
He's out.
He's out. I'm out. Go down Ramon's House of Math.com for more.
Oh, boy.